Hello and welcome to this nice little session on understanding variables. Now this is really confusing, or it can be confusing, so we have to listen carefully, and then if we don't understand, I really hope that you will go and see your teacher. You need to understand this for when we have to write our science reports. So make sure that if you don't understand it now, don't leave it. See your teacher really early on and get it clear in your mind. So that poses the question, what is a variable? And as you can see, I've defined a variable as any measurement or condition. And by condition I mean things that we do or things that we manipulate that could change an experiment, like how long we do it for or things like that. I'm going to go through some specific examples as we go through. Now, it's most important, I'm going to step right down to the bottom to start off with. It's most important that we always have a fair test. And by a fair test, I mean that we only ever change one thing at a time. We can go back and do the activity again and change something different. What we're trying to do is to try and look at the cause and effect idea, that this one variable, by changing it, we cause something to happen, and that's most important. Now, a fair test is one that other people can trust and use. So in other words, they know that the information is valid and reliable, and that's super important. So if we're going to do that, then we change one thing and we see if it causes the measurement to change, what we're going to measure. And this is why we have to plan out these things nice and early. And you might have seen a variables grid, and we'll see one later on as well. Now the variable we decide to change is going to be called the independent variable. So it should be clearly shown in your write-up, even at the stage of you putting a subheading, variables, independent variable, dash, and then name it. The one we're going to measure, in other words, we're saying the changes will depend on what happens to the other one, are called the dependent variable. And we've got to plan carefully. Now your teacher is often going to give you some advice about what to do there. So pay attention in class and think about it. If you wanted to have a different dependent variable, maybe it's a good idea to talk with your teacher about it too. Now, to make a fair test, that means that everything else that we would describe as a variable must remain unchanged throughout the activity. In a future activity, it can also be changed, but in the current activity we're doing, it cannot be changed. So you would put a heading, controlled variables, and you should tell the reader what you are going to control and how you are going to control them. More about that later. I hope this makes a little bit of sense so far. So let's have a look at examples. Right, when you are brainstorming with your partner before you start your activity, you can think of the common variables we have in the science lab. Now, so far we've learnt about the amount of a solid. And if we're talking about the amount of a solid, we're talking about its mass. And of course we're going to use our electronic balances to measure it. So we can change the amount of mass and see how it affects what's going on. So that's always a possibility for our variables. So maybe it's something that should appear on our variables grid. More about that later. Let's look at what other common ones we could have. Now, I've only done a few of these. There are ones that can be done as well. If we're dealing with liquids, we don't usually use mass. We use volume and get our measuring cylinders out. And so we know the volume and know what's going to happen. We change the volume. Okay, so that's another common one, but especially if you have liquids. If we have solids, we tend to change that. If we have liquids, we tend to change that. One of the classic ideas is changing time. How long are you going to let the interaction happen? Are you going to measure after every minute? Are you going to measure after 5 minutes? Are you going to wait and see what happens in 10 minutes? Or are you just going to let it happen, and when something stops, you are going to, or when you observe that it has stopped, you are going to then measure the time. Time is often part of our control, but time can also be part of the things we measure what goes on. In other words, the time it takes for something to happen. So it can be quite often a dependent variable. One of the things many people don't think about is what we use, or what our lab activity is happening inside of. If we're doing a lot of lab work, we then might have a beaker or a test tube or something like a conical flask or a variety of other containers our reactions happening in. So we should make sure that if we start off with a beaker, we don't suddenly change to this test tube. We don't suddenly change to a conical flask. This is often one of our control variables. We think about making sure that we keep the same container all the way through, but it's another one that is easy for us to mention. Obviously, if we're dealing with some solids and dealing with other things, we might measure the length of something. Instead of measuring its mass, we might measure the length. Now, a classic experiment might be a reaction between magnesium ribbon, a piece of magnesium, and acid. Now, because the magnesium is so light, measuring the mass is a little bit harder to do, so we normally measure it in its length. We can deduce or extrapolate that from its length into its mass, but that can be done later. But we tend to look at things like length if we're doing these. You might also be looking at the length of a piece of something or other you're using. Let's say on our pendulum, we measure the length of our string. So it is one of our variables, and we saw that in our first one we kept it constant. In our second one, it became the independent variable. In other words, we decided to change and see what would happen if we changed the length. To do with the containers, we also have the size of the container. All right, you might start using a beaker 600. And because you can't find any other 600 beakers, you change the size. Now that's wrong, because you've changed the variable. If you start off with this size, you must continue this size all the way through your activity. If you use this size, the same applies. If you use this size, the same applies. Because each one of these can change the way things happen, especially when we're dealing with chemicals. So there are some samples of variables that are commonly found in many activities in the science lab. So they're the things you should be able to then think about when you are doing a variables grid. So if we're doing a variables grid, we could put those things into here, one in each box of the variables, to work out what we could change and what we could measure. If we don't think about it and just go in one direction, we might end up picking the wrong variable and nothing might happen. Now, while that's good, because we can then cross it off our list of things that might cause the change, we might have, if we had have thought a bit longer and filled out our variables grid and put all the variables we can think of in there, we might have actually come up with a better activity. And it's also something we can look at when we have to evaluate our method. If we evaluate a method, we say, oh, next time I might change this instead of changing this one over here. Or I might measure this one. All right, I haven't got anything written in here. That's blank when we start, and you gradually fill in. I hope that has made variables a little bit easier to understand. And I hope you are going to have no difficulty with them at all as we go through this year and in the future years in your science studies.